It's a short video discussion on how to interpret confidence intervals, especially in context of hypothesis testing. So let's review the hypotheses first. Let's look over here. Here's our null hypothesis. Null hypothesis is either going to be one of the two parameters, either mu or p equal to a number, or if it's the two sample comparisons where we have a difference of means or a difference of proportions, then that'll be equal to 0. The alternative hypothesis, that's this one. Again, it's the same idea. It'll either be mu or p equal to, or pardon me, not equal to, either not equal to a number, or again, a difference of means or a difference of proportions, not equal to 0, or greater than, or less than. Is really the only ways we can structure the alternative hypothesis. So let's take a look at the three ways this works out then. Let's go over here and take a look at this one first. Now, when you have a confidence interval, and I've put these on number lines, by the way, that's what the horizontal line represents. We have a lower bound and we have an upper bound. Dead center is always our estimate, the point estimate. It's either going to be y bar or p hat. And the interpretation of the interval is any value in this interval is equally plausible as the true value of the parameter or the difference of parameters. For instance, here we have outside the interval either mu or p, and this would be evidence to reject the null hypothesis, because if the values inside the interval are plausible true values, then any value outside the interval must be implausible. I almost put the wrong prefix on that. English is hard, sometimes. The point is, what we have here is the interval is entirely greater than whatever the parameter is. And that's evidence to reject the null hypothesis at whatever level of significance we happen to be working with at the time. Now, how does this look if we flip things around a little bit? Well, again, we have a lower bound and an upper bound, and in the middle we have our estimate. But now the parameter is again outside the interval, but now it's greater than. So that means we reject the null hypothesis as well for the same reasons we rejected in the previous discussion. The values that are possible or plausible for the parameter lie inside the interval, but our parameters are outside, so they're implausible or unlikely to be true. And that just leaves us our last line. Here, let's take a look at this one. Again, a lower bound, an upper bound, and here we have our statistics inside, our estimates, but now we also have our parameters on the inside. Recall again, anything inside this interval is equally plausible as the true value of the parameter. And now the parameters are inside the interval. And the interpretation of this is, well, we can't tell them apart. We can't tell all the values apart from the true value. So all we can do then is fail to reject the null hypothesis. That can be our only conclusion. Now, if we were talking about this in context of confidence intervals alone, we would say in context of this thing, let's say the 90% confidence, we could say we're 90% confident that the true value of the parameter lies between whatever the lower bound number is and the upper bound number. And of course, with both the estimate and the parameter inside, it's probably next to impossible to suggest that there's a statistical difference between the two things, so we fail to reject the null hypothesis. It's just as simple as that. Now, on the doodles on the screen here, I only have the single instances of either mu or p, but remember that this also applies for the difference between two means, or the difference between two proportions. And that really is all there is to interpretation of confidence intervals, so let's just leave it there. And we'll see a couple of examples and put this into practice. And that ends this video.